CEO of CryptoMove. So just a really quick presentation about what we're doing, some of our use cases that we think might be applicable to this cluster, and open it up for questions. So CryptoMove is a startup based out in Silicon Valley, and we're working on data protection. Before I get into exactly how our platform works, just talking about some of the challenges around smart cities data security, some things that we've learned in conversations prior to this conference, as well as a lot of topics that have come up here over the last couple of days. So first, a gentleman mentioned earlier about the asymmetric advantage that adversaries have. In the smart cities arena, when you have a proliferation of sensors, cameras, and devices, that asymmetric advantage is really all about time. And there's a idea that over time, no matter how much security or complexity in a system, an adversary is able to study it. And there's a concept called the Lockheed Martin kill chain, which maps out the average cyber attack. The first step is always reconnaissance, trying to map out the resources and where the data is. So there's this concept that originated in academic research and military research. DHS, S&T has done a lot of work on it, called moving target defense. The idea of moving target defense is to flip that time advantage against the attackers. To say, whatever our defensive resources are, let's shuffle them, like a shell game. And so as time goes by, now the adversary is seeing a changing playing field, and things are actually more difficult to map out. So when we think about that asymmetric advantage that adversaries have today in the smart cities arena, it's all about time. Data volume growth came up yesterday, something like multiple terabytes an hour. Too much data is being generated by sensors to even save effectively. And as a consequence of that, a lot of data has to be processed at the edge, right? We want our sensors and our smart cameras to deliver insights back into the cloud or data center, not raw data. And that changes data protection. It means you have to protect sensitive data at the edge, as well as in some kind of central storage system. There's also proliferation of secrets and keys. So generally, key management and encryption has never been applied at the scale that currently exists and will continue to accelerate in this arena that we're talking about today. You could potentially have a different encryption key for each sensor, or even multiple keys based on different applications accessing them. That proliferation of keys combined with what, in terms of more modern development processes, are new types of secrets. API tokens, certificates, are all things that also have to be protected. So it makes it very difficult. And there's this question of future-proofing. You install a traffic camera or video or sensor or anything, something under the road, it's hard to go in and replace that. The history of data security when we focus on encryption is one of constantly deprecating encryption algorithms. So we need to think about ways that we can be flexible as computers get faster. May have run into some of the research around quantum computers. We need to be aware of what to do when encryption fails as the last line of defense. And so these are all sort of the some challenges that we think matter, and it's what we're working on at CryptoMove. So CryptoMove is a decentralized moving target data protection platform. Essentially what CryptoMove is software that can go onto embedded platforms, connect to embedded devices, and protect data through a variety of methods. And the fundamental innovation is, instead of leaving data in one place on, let's say, a small disk attached to a Raspberry Pi, we're actually splitting that data up into pieces, encrypting the pieces, and shuffling it around. That can happen on one node or across many nodes. So at scale, you can think of CryptoMove as this decentralized data vault where the data is continuously moving, re-encrypting, changing, mutating, potentially getting padded, expanding. So as an adversary attempts to look at it, study it, or even exfiltrate it, they're just getting little bits and pieces. They're not adding up. It's more difficult. And the encryption algorithm starts mattering a lot less, because the fundamental prerequisite to any type of cryptographic attack is identifying the data, is having it. And the way we built it is agnostic to the algorithm. So one of the things we're doing with DHS S&T is we've put CryptoMove onto embedded Linux devices, connected them to real-time video cameras, and put them onto drones. And part of the idea is that certain algorithms are too heavyweight, but if you have a system like this, you can add in security. You can also swap and plug and play different algorithms. So just to quickly talk through a few of the use cases that we're seeing. So CryptoMove was in stealth for about 5 years. We launched in January of 2017. And so in about a year since launch, we're working with multiple private sector companies in Fortune 100, Fortune 50, Fortune 20, as well as DHS and CBP. I think that we came to this conference on the suggestion of some of our S&T colleagues because the work that we're doing to put CryptoMove on the embedded drone, that's the same board as a Raspberry Pi or that exists in many of these edge city scenarios. Also, the work that we've done to essentially integrate CryptoMove into a live streaming video camera applies to cameras anywhere that they may be. And we've also done it with sensors. We've had certain use cases where you could bifurcate data security from keys and secret security. And so one thing that's very powerful is enabling the native encryption of many of these technologies. Somebody mentioned earlier, so a lot of these devices can encrypt on their own. So that's great. Let's do that as much as possible, as quickly as possible. But in order to do that, we need a good, decentralized, potentially edge-based key management platform for those keys to be securely stored and managed. And so we've done that with CryptoMove. Obviously cloud, I don't want to get too much into it, but we have spoken with people at this conference in the last couple of days about how cloud can help drive and accelerate smart city initiatives. And in terms of distributed ledgers, to the extent that distributed ledgers start being used in the smart cities context for various use cases, they can only really store hash values on them. Any associated actual data, let's say my traffic records, are not going to be on the blockchain. They need to be in some kind of secure off-chain storage. So we're working with some banks in Europe on this type of a use case. It's very applicable to what you might see from cities sharing data about different users and trying to be privacy conscious of it. So just to wrap up, we're CryptoMove. We've been in business for quite a while, but only launched recently. Our team is very experienced in cybersecurity. Billy back here is our head of business operations. He's early at IDX. We have some of the first people from Tanium, one of the fastest growing cybersecurity startups of all time. And we just raised our Series A, and we're backed by Social Capital, Tim Draper, and some others. And we are global, so we have customers in Japan, Europe, and the United States. So that's basically what we're doing. We're very interested and eager to apply our technology to the smart city space. We think it's the same technology, just a different application. And there's some exciting things here. So to the extent that we can provide any insight about what we're seeing, or help, we're happy to talk to anyone. So thank you. If anyone has questions, happy to take them.
Questions? You obviously explained it very well. Thank you.